Hello, welcome to episode 5 of this series. In this episode, I want to talk about semantic versioning and dependency management. During the previous episodes, we kind of, saw the SemVer or semantic versioning concept. But in this episode, we are going to, dive deep. We are going to explore it in full detail. So the goals of this episode: understand semantic versioning, explore this concept of transitive dependencies, make airline bookings depend on airline flights, simulate a version mismatch to analyze its impact, and learn about floating versions, version ranges, and version pinning. So let's get started. Let's first explore the concept of SemVer or semantic versioning. So semantic versioning or SemVer, it's like a system that gives your packages meaningful version numbers. So the version of your package is composed of 3 numbers, and by using these 3 numbers, you can indicate the changes that each version has introduced. So you can, indicate what kind of changes were made to this, specific version, whether they are safe to use, whether there are some breaking changes or not, and how they might affect other pieces of the code. So the consumers, for example, of that package. So this is like, again, a system of versioning your packages. Let's talk about the format. So the format of a SemVer or semantic versioning is like this: major version, minor version, patch. And then inside a square brackets, you can see pre-release and build flags. We are going to talk about these as well. But before I talk about pre-release or build, I want to talk about these 3 numbers or portions of your SemVer or semantic versioning. Each one of these numbers, major version, minor version, patch, each one of them tells a story. Let's take an example. You see, this is the major version, number 1, minor version 0, patch 0. So this is one example of a version number that is using SemVer or semantic versioning. So this is, the first stable release. So the major version is 0, the major version is 1, minor version is 0, and patch is 0. So this is the first official, release of this package, which has this, this version. It's stable and ready to be used. The major version is 0, minor and patch. The major version is 1, minor and patch are 0. Then suppose one new feature is going to be implemented in that package. So you need to increment the version of that package. So this would be the next version number of that package. So again, notice that the major version has stayed the same. It is a still 1. Then the minor version has incremented from 0 to 1, and the patch number is still 0. This means that a new feature has been added because you have increased the minor version, but there are no breaking changes. So the package is still compatible with the code that was using the previous version. So this version 110 and the previous version 100, both of them are compatible. The reason for this change in the minor version is that a new feature, a non-breaking change, has been introduced into the package. So we added something new, but your old code won't break. So there are no changes in the, let's say, public API of this package in this version. Now, let's suppose we have found a bug. So there are no new features added, but we have found a bug and we are going to fix it. And we have fixed it now. So again, we are going to release a new version. But This time we are going to increase the patch number because there are no new features added, so the minor version will stay the same. There are no breaking changes, the major version will remain the same. But because of that bug fix only, we are going to increment the patch number. So fix the bug, didn't change how things work. The old code can, of course, still continue using this new version of our package because there has only been a bug fix. So there are no breaking changes, and this is why we have increased only the patch number. Now suppose after a while, we are going to implement significant changes. So breaking changes, changes that will break the consumer code that was using the previous version of this package. So in this case, we are going to reset the minor and the patch number, and we are going to increase the major version. So something big changed. Your existing code may need to be updated. There are some breaking changes in this new version of the package. So the major version has increased, the minor and the patch number are reset. So these are, the different concepts of these, three numbers, major, minor, and patch. Now I want to talk about the labels or the flags. So take a look at this example of a SemVer. So the major version is 1, minor is 2, patch is 0. Then we have this part. It says beta period 1. And then this means that it is a pre-release version. So this kind of adds a pre-release label to your SemVer, and this kind of means that this is a test version only for developers who are wishing to use a pre-release version of this package and provide feedback. So it is not like an official release. There might be some issues, there will be improvements, but this is like a test version for this pre-release version of this package. So, developers who are willing to use this pre-release can of course do that and provide feedback, but this version is not suitable for production. Again, this is a beta version. And there are other, labels that you can use. For example, you've got alpha, you've got beta, you've got RC, which stands for release candidate. So for example, you can have this SemVer, major version 1, minor version 3, patch 0, RC1, release candidate 1, or beta 2, right? So let's understand the pre-release labels like alpha, beta, RC. These are special versions used before the final product is released. Again, they mean that this version of this package is for testing, for getting feedback, not for production. It is like a preview. So again, as you can see here, we've got our three numbers, major, minor, patch. Then we've got this label like beta, alpha, RC, and then we've got a version again for this label. Let's take a look at an example. So major 1, minor 2, patch 0. Then we've got the alpha label with number 1. This is the version of this label. So this means that we are just getting started with the development of this new version of this package, so things might break. For example, in our domain, suppose you are building a new flight booking system. So this version is like the first initial rough version of this package. It is not fully tested, it is not complete. Things might break, there will be improvements, but this is the alpha version number 1. Then there is the beta version. So after a while you continue working on that package and you decide that you are going to release the beta version of your package, beta version number 1. Beta means that most features are done, they're tested, you can try it and provide your feedback. So it means that, for example, in our domain you have added different features like search, booking, cancellation, and then you release this version of the package, number 120 beta 1. So these users can now, at least compared to the alpha version, start using this beta version and provide their feedback. So there will be some minor improvements. There will be some bugs here and there, but we would say that it is, closer to the production version compared to the alpha version. So the first rough version, again, remember, is the alpha. After a while, you decide to release the beta version. And then after, working on that beta version for a while, you release the RC or release candidate. So this means that this version might be the final version of this version 1.2.0 unless we find like a major bug. So everything is tested in an RC version, and you consider this version as the version that will probably make its way to production, and then you publish it 1.2.0 RC1. If no serious issues, bugs are reported, this will of course become the stable version 1.2.0. So this is the way it works. Now let's continue talking about the stable version. So again, after you done your the RC version, and you decide that there are no issues in the RC version, you decide that this version is ready for everyone to use in production, so you release your stable version. After feedback and fixes, you release the version 1.2.0. Now it's official, it is safe to use in real airline booking systems. So try to understand the SemVer system, semantic versioning. You've got major, minor, patch versions, you've got labels, RC, beta, alpha, and you will see these labels and this SemVer system frequently when you start developing Nuget packages, or when you try to manage the packages in your system. It is essential to understand the meaning behind each version, so that you can safely use the next versions of a package in your code without worrying about your code getting broken. So why it matters in Nuget? When you run this kind of command, CLI command, .NET add package, and then the name of the package that you want to add, for example, Nuget uses the rules in SemVer to pick the safest version compatible with your project to avoid breaking your code unless you explicitly allow it. And I will tell you what it means to explicitly allow a new version of a package to be installed. And of course, that means that you risk breaking your code. And again, it lets you control which updates to accept. Are you safe with, are you okay with the version of a package that you're using to be increased to the next major version? Or do you want to keep the major version intact and only continue with the new patch numbers and minor numbers, patch versions and minor versions? So you can control all of these when you introduce packages in your application, in your program, in your CS project file of your project. And I am going to show you that. So let's get to the code now, and we will revisit SemVer in the future. Let's add dependency between our packages. You know that right now we've got the bookings package, right, and the flights package. What I want to do is to add a dependency. So in our airline bookings project, we want to update the booking class to reference the flights, type. So in our booking, let me show you. So in our booking, not in our airline core, but in our airline booking, if I go to this type, you see that the flight number is a string. I want to change that. I want the flight instead of flight number, and it is of type flight. And of course, this flight is created in airline bookings, airline flights.entities. So let's do that. I mean, if I come here, if I get rid of this, I can go ahead and say, you know what, I want a flight, and then flight that gets set, and then I'm gonna new this property. And of course, this is complaining because it cannot find flight, and I can go and add a reference to airline.flight flights. And if I do that, I'm going to get the namespace here. And of course, if I go to my CSProj file for these airline bookings, I see that I've got a project reference to this, CSProj file of my airline flights. This is a project reference. I want to talk about that. So add a project reference for development time. Right click on your project, add a project reference, and you will see this node right in your CSProj file. You are adding a project reference. You now have a dependency at the project level. But when we pack it, we want Nuget to understand this is a dependency too. So basically, our Nuget package is going to have a dependency on another package. Now we want to update the program.cs file in our console app to use the flight type, and I am going to do that, and then I am going to update my CSProj file to kind of reference the, take a look here, reference the package. Right now I've got a flight here, I've got a booking. I don't have my flight number anymore, but I've got my flight property, and I am going to assign that to the flight I have declared here. Now, as I showed you, when you add that dependency, project dependency, you get this project reference in your CSProj file, but that is not enough. We want to remove that project reference and install that airline flights package, the Nuget package, right, in our airline bookings. This will add a package reference to our CSProj file, not a project reference. So let me do that. I mean, I have a local feed, right? I showed you my local feed. I set up my local feed in previous episodes. So let me do something. I'm going to remove my project reference, and I am going to add a dependency from my local feed to the flights Nuget package. There are two versions right now. I am going to continue with version 1. I'm going to install this package into my class library. Right now I've got a dependency on this package, not on the project itself. And of course my code will continue to work, right? But the difference is that if I go to the CSProj file, I do not see a project reference anymore. I see the package reference, and then I've got the SemVer of this package. So it means that this library is going to have a dependency on these airline flights with this version. Now let me tell you what that actually means. So yeah, this creates a project reference, a package reference to that airline flights Nuget package, and then of course you can add different let's say metadata here as well. For example, inside of your property group, you can go ahead and add different metadata, like for example the version number of that package, airline booking, the package ID, which we'll be using when we want to publish to Nuget. Then we've got the author, we've got the description, we've got the flag, generate package on build. Whenever you build your class library using a release profile, it means that the Nuget package will also get packed. And then you've got your dependency as well. So I can go ahead to my CSProj file here, right, and add some of these metadata to my Nuget package. I'm going to remove this. So these are some of the things that you can do. Now, why not use project reference? We are using package reference. Project reference is for development only when you are developing your app. But when you want to pack things, when you want to pack your Nuget package, you need to use package reference, because package reference will help Nuget to resolve the dependency when you want to install packages in your applications. Now what we can do is to repack the Nuget package. So airline bookings, we can kind of pack that again and copy it from the output folder and paste it into our local feed, right? And this new version of this Nuget package now includes a dependency on the airline flights and this version number. So I'm going to pause the video and do that. So I did that. I packed my package, and now I have pasted into my local feed folder. You can do that on your machine as well. Now let's consume this new version of this airline bookings, package. Again, remember that airline bookings now has a dependency on the airline flights. So Visual Studio will automatically, add airline flights as a transitive dependency. Let me go ahead and do that. In my consumer app, I am going to, do this. So I've got this consumer app here, right? And let's do this. I think in the notes, I am doing it in my, inside of this flight consumer app. So let me go ahead. Inside of flight consumer app, the program.cs is here, the dependencies, the Nuget package. We've got a Nuget package dependency on airline flights. I can go ahead and remove that. And of course, I will get issues here because it cannot find this anymore. But what I can do is to go to my Nuget packages and airline bookings. Take a look here. So there are some information. Of course, these are, from our program.cs file, right? Like the description, the version, authors, and the dependencies. It says that it has a dependency. Let me zoom in so that you guys can better see. It has a dependency on this version of airline flights. So the airline flights, Nuget package on which we have not a project reference, but a package reference. And I am going to talk about these, dependencies and how to pin your versions in a bit. So that means that if I go ahead and install this, if I install these airline bookings, I will get the airline flights as a transitive dependency as well. So that is, the reason for this is that we declared a package reference in our airline bookings. So if I take a look now, I can see that I've got my airline bookings and airline flights as a transitive dependency. And of course, the code will continue to work. So works even though you didn't install airline flights manually, because Nuget, understands this transitive dependency and installs it. Now let's talk about version ranges. When you use Nuget package, you can choose which versions your application will use or is allowed to use. So version ranges help you control updates. When a Nuget package is updated, you do not want to blindly update to that new version. You want to be in control. You want to decide whether your application is allowed to, continue with the new update of a given, Nuget package. So for example, if a Nuget package has introduced a major version, you probably don't want to update blindly, because that means that you will have some, broken code in your application, because major versions of Nuget packages usually mean that there are some, breaking changes. So in order to avoid breaking changes, you want to control the behavior of your application in terms of using the updates of a Nuget package. And you can control that using version ranges. Right now, in our CS project file for airline bookings, we have this code. So we've got a package reference on airline flights, and this is the version we are using. So I can show you that again. Here you can see that I've got this dependency declared. This means that this airline bookings package is allowed to only use version 1 of airline flights. You see, the version is explicitly mentioned here. So it means that no upgrades or downgrades, it's locked to this exact version. Even if airline flights kind of, introduce a new update, airline bookings is not allowed to continue and, use that update, because we have explicitly locked the version on which we wish to have a dependency. But we can control that. There are different, ways to control that. For example, take a look at this. So you've got this version number, these are SemVers, right? And then you've got a square bracket and a parenthesis. Now, what does that mean when you, set your version like this? So this has this meaning. This means use version 1 or higher, but don't go into version 2, which might have breaking changes. So this means that you can use this version, and any minor versions or patch versions are okay, but you do not want to go to version 2 because version 2 will contain breaking changes. So this is safe because you will get all non-breaking updates in this version. So for example, your app will be okay with using version 1.11, 1.21, 1.31, and so on. So all minor versions are, all, let's say, patch versions in the major version of 1, but do not go to version 2. You can have this example. So a pair of parentheses, you've got the first version and you have nothing here. So this means that use any version greater than 1. No upper limit, it will pick the latest version available. This is very risky because of course newer versions, major versions, will have breaking changes. So it will be a little bit risky. Again, you are not defining any upper limit for that package. And it means that you can use any version greater than version 1.0.0. Then you've got this example. So 1 dot asterisk. What does that mean? Inside of quotes, by the way, not parentheses, not a square brackets. So this means use the latest available 1x version. So it kind of means that I want to stay in version 1, but I want the newest version. So for example, if the newest version for major version number 1 is 1.99, go ahead and install that minor version and patch number. So you don't control exact minor or patch versions. You are okay with any minor version, any patch number, but you want to stay with version 1 as your major version. The next one is asterisk, which is of course very risky. It means use any available version, even future major versions. You're okay with everything, right? This is again very risky. You might get updates that break your code, and it is best for quick tests, not for production apps. So for your production applications, of course, you need to be in full control of what versions of that package you want to install. Real life analogy. Imagine you use a coffee machine, and this is the model of that coffee machine. So number 1.0.0, it means you want exactly that model. And then this version, take a look at the square bracket and the parentheses. This means that you are fine with any model from 1.0 up to just before 2. You do not want to get to 2 because 2 will introduce breaking changes, because model 2 might require new filters or cops, so breaking changes. 1.0, it means you trust any version of model 1. You do not care about the minor version or the patch number. And then asterisk, of course, it is very risky. It means that you do not care about what you get. It would be very risky. You're okay with anything. Again, this is how you control what versions of a Nuget package are allowed in your application. Is your application allowed to continue to have the updates of a given Nuget package or not? You want to control everything, and I think you should, right? In production apps, you want to be in full control of the versions of the packages that your application uses. So why it matters? Again, because you want your production code to stay safe from breaking changes by avoiding major version bumps. Remember, major versions introduce breaking changes. You want to get bug fixes and features, minor versions, and patches automatically within a safe range. And you want to control stability versus flexibility in your project. As a final example, let's simulate a version conflict. Let's say you have this scenario. So you, for example, upgrade airline flights to version 2. By the way, I am going to leave this as your homework. You can, clone the repository using the link in the video description and do this as a piece of homework. So you upgrade airline flights to version 2. So this means that there are some breaking changes. We have a dependency on airline.flights. But airline bookings still depends on version 1. Then try to reference both of these. So go ahead and reference airline flights 2 and airline flights 1, which will airline flights 2, and of course reference airline bookings 1. So this dependency goes into your consumer app. So your consumer app will install this package, the second version of airline flights, as well as the airline bookings, which has a transitive dependency on airline flights. This will cause a version conflict in your application, and Visual Studio will give you this message because you've got two dependencies on one single Nuget package. There is one single Nuget package called airline flights. You have installed version number 2, and another Nuget package that you have installed has a dependency on number 1, version number 1 of this package. So this means that you've got two separate versions of the same package, and you will get this message. Multiple versions of airline flights are referenced, and so on. We will talk about conflict resolution, in future episodes, but I think that would be a great practice for you. Just as I said, clone the repository using the link I have provided in the description. Go ahead, clone it, practice with it, and see if you can, simulate this version conflict. The summary of this episode. In this episode, we added, Nuget dependencies between our packages. So right now, the airline bookings has a Nuget dependency on airline flights. We repacked and tested transitive dependencies. We saw that in the consumer app. We learned how to specify and control versions. And we also learned a lot about SemVer, right? And now you understand how SemVer protects your projects from breaking changes. So I think two of the very most important topics of this video was that SemVer thing. We kind of understand the SemVer versioning and SemVer system now, and we know how we can control the behavior of our application in terms of using the specific versions of a Nuget package. Thank you so much, guys, for watching this video. I will see you in the next one.